So today, Kipsters will be able to interchangeably write equations, word problems, T-charts, and graphs. So basically, this is kind of the culmination of this unit, where you should be able to take any one of these four things and then create the other three to represent the exact same situation. So we're starting down here. When we're looking at this, the piece of information that we're given is which piece of information are we given? Axel. Yeah, the gallons and miles, and they come in the form of a T-chart. Now, what is weird about this T-chart? Jalen?
That's sideways.
Yeah, that's sideways. Does that matter, though? No. Okay, so we've got to make sure that we know which of these is X and which of these is Y. You can see that you've been given labels on your coordinate grid. There's not given you the axes yet, but you've been given the units. So which of these is X and which of these is Y? Jesus. Gallons is Y and miles is X. All right, so we need to make sure that we have that in our brain, that gallons is Y and miles is X, because we're kind of used to seeing the X be first and the Y be second. So this is a little bit strange. We just need to make sure that we're really careful about this. All right, so I know that I need to graph all three of these points. So I know that my X's are all positive and my Y's are all positive. So I'm going to go ahead and say, since everything seems to be all positive, that I do not need any of the negative parts. So I'm going to put my axes on the bottom and on the left-hand side. Now I need to graph these points. My miles seems to go from 0 to 90. I definitely do not want to count by ones because I'm not going to have 90. So I'm going to count by, what do you want to count by? Tens? All right, let's do tens. So I'm gonna label every other one. So this is 0. I'm gonna skip one, label 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. All right, so I've just labeled every other one because I don't have space to label them all. Gallons. It looks like in the gallons we only have to be as high as 12, and then it seems to decrease from there. So what do we want to count by on the y-axis? What do we count by on the y-axis? Jalen? Anybody have any other ideas? 2? 2 is fine. We can't count by negatives, so we're looking for a positive interval. 4 would be okay, but that 10 is not going to be divisible. How about 1?
Yeah.
We've got 20 boxes. Are we going to all fit?
Yeah.
Oh, yeah. Hey, why don't we just count by 1? I'm going to label every other one. 2, 4, 6, 8, 10. I only label... So you'll notice that I'm labeling counting by ones, and I normally don't do that. The reason I'm doing this is anytime I put a scale on one side, it gets confusing, and you kind of make the assumption that the scale is the same for both. So that's why, even though I don't normally show counting by 1. All right, so I'm going to graph these points. 0, 12. So 0 miles is 12 gallons. And 30 miles is 10 gallons. That's here. And 90 miles is 6 gallons. And get a straight edge. And obviously mine is not a very straight edge, so obviously you want something better than that. And so here, this is the first part that you would need to do on your test. Your graph. Now, you didn't have to do the graph first. You could have done the equation first. How can I find the equation using the T-chart? How can I find the equation using the T-chart? Our horizontally aligned T-chart. Yeah, find the change in y and the change in x. So the change in x, this is an increase of 30. This is an increase of 60. This is a decrease of 2. And a decrease of 4. And so my change in y is -2. My change in x is +30. And so I want to simplify that to -1/15. Y equals -1/15 x. And then what's our b? Jefferson. 12. We're actually given b in this particular case because we're given the y-intercept. And we would know that because we graphed it. This was our y-intercept, so it's 12. So here's our equation. I should have given you a little bit more space for that. My apologies. Y equals -1/15 x. Now, if we go through and we put our units on that, we know that the x is supposed to be miles, which means this 15 down here needs to be miles. And this one on top needs to be gallons. The y is supposed to be gallons. And that means this 12 is also going to be gallons. If we put all the units on it, now we can start writing our equation. Now, what we see here is a relationship between miles and gallons. So we know our rate's going to be 15 miles for every 1 gallon. The question is, we need to find a way to make sure that it is a decreasing rate. So this would make sense in something where we are using gallons of gas. Okay? So we want to write a word problem where we are using gas at a rate of 15 miles per gallon and that we are starting with 12 gallons. So I think through this. I start with my starting point. I have 12 gallons of gas. My car uses, this is the negative portion of it, 1 gallon every 15 miles. And how many gallons are left? That's the important part. After X miles. Cool. All right, let's repeat. Which is X and which is Y? Time is X and temperature is Y. So this is the opposite way that the previous one was set up. Last time our X was on the bottom and our Y was on the top. Okay, so the reason we know this is because we're looking at how things are labeled. All right, so I'm going to go ahead and I'm going to do the equation first for this one. Why not? This is my change in x. This is my change in y. This is an increase of 4, increase of 12. This is an increase of 2. This is an increase of 6. So my change in y, remember, that's on the bottom this time. My change in y is 4. My change in x is 2. So that simplifies to 2. So y equals 2x plus, what's my b? Careful. Jorge. You want to say it's 4 because we see that 0 down here, but this is not our y-intercept. This is actually where it hits the x-axis. So what are we going to have to do? We're going to have to solve for it. Or we're going to have to graph the equation, one or the other. So I'm going to go ahead and graph the equation, and I'm going to say, I hope graphing my equation with a straight edge is going to show me what my y-intercept is. So I'm going to go ahead and say, oh, I definitely need negative y's. I don't need negative x's. So I'm going to put my y-axis here because I don't need negative x's. I do need negative y's. I need to get at least to negative 4 and have as much as negative, or as much as positive 12. So I'm going to go ahead and put that there. So negative 4 goes with 2. And 0 goes with 4. And 12, that's going to be way up there, goes with 10, which is way over here. All right, so 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And if I get a straight edge, did this help me find my y-intercept? Cape yes or Cape no? Did this help me find my y-intercept? No. What could I possibly have done that might have helped me find my y-intercept?
Go back.
Yeah, if I had put my axes in a different position or maybe counted by a different number of units so I had more space, we can see that if we extend this down, eventually this would cross the y-axis down here, but it's off our grid, so we can't really use that. So what's the other way that we know to find the y-intercept in this particular case? Jefferson. Yeah, solve the equation. So we'll come down here in our space to create the word problem. Y equals 2x plus b. I'm going to go ahead and plug in the last point because it's all positive numbers. So my y there was 12. 2 times 10 plus b. What do we know about b, though? What do we know that should be true about b? Should it be positive or negative? Yeah, it should definitely be negative, because we can see that from our graph over here. And it should definitely be something below negative 4. So I'm going to get 12 is equal to 20 plus b. Negative 20 plus 12 is equal to 20 plus negative 20 plus b. Negative 8 is equal to b. So y equals negative 2x plus negative 8. All right, let's create our word problem. I'm going to create my word problem by putting the units on here. The y is degrees, which means this is negative 8 degrees, which means this is 2 degrees per 1 minute. And we are multiplying by x minutes. All right, so I have an increasing temperature. That's proof of my increasing slope. So I have frozen veggies at -8 degrees Celsius as they thaw, in other words, start to warm up. Their temperature increases 2 degrees per minute. What will the temperature be after X minutes? So as you can see, the way I write these word problems, I make it very formulaic. I start with a statement about what our y-intercept is. Then I move on to a statement about what the rate is. Temperature is increasing. And then I move on to a question that tells me what I'm asking for what my y value is in terms of my x. Okay? Very formulaic. You can follow that same pattern. You can make it more difficult on yourself by coming up with these long, beautiful stories. Totally fine. But you've got to have these three components. All right? And the last one. Last one's different. We're not given the T-chart, we're given the graph. So I have no scale here, so I'm assuming that everything's counting by ones. I see up here that my y-intercept appears to be at x is 2. Okay, so here, let's go ahead and label this. Let's say the top is my x, the y is my bottom. What are the units of my x? What are the units of my x? Axel?
Hours.
Yep, hours, time. What are the units of my y? Aaliyah? Miles. So my first point is here when at 0 hours, we're at 20 miles. I can find another point. As I come down, it looks like there's definitely one right there. This is going to make it really easy. At 1 mile, or at 1 hour, I've decreased 2, so I'm down to 18 miles. And actually, this makes it really easy because this is a change of x is +1, change of y is -2. So change in y over change in x is -2 over 1. So as I'm getting over here to write my equation, y is equal to -2x, and we actually know our starting point because it's clearly graphed there. What's our y-intercept? Esme, what's our y-intercept? 20. And we'll go ahead and fill in this T-chart. If we continue to follow this pattern, increase 1, it's going to give me 2, decrease 2, it's going to give me 16. So I will ask you to completely fill out all of the T-charts on the test, even if you don't necessarily need all of the points. All right, let's go ahead and put the units on everything in our word problem, or in our equation, so we can figure this out. So our y we said was miles, which means this 20 is miles. And our x is hours. And -2 over 1, so this is hours on the bottom. And -2 miles. So it looks like I need to find a way where I am decreasing something at a rate of 2 miles per hour. That's the negative, decreasing rate. And I'm starting at 20 miles. So, I'm going to start with my starting point. I am 20 miles from home. That's that nice, easy statement. I am 20 miles from home. I walk. Am I walking towards home or away from home? I need a decreasing rate. So if I'm starting 20 miles from home, I need to decrease that. So I'm walking towards home or away from home?
Away.
If I'm walking towards my house, is that going to decrease how far away I am from my house or increase it? I hope so. Let's say I'm standing here and I am 4 feet away from Danilo. If I want to decrease the distance from Danilo, do I need to walk away from him or toward him? I am now 2 feet away from Danilo. I need to walk toward him because I'm decreasing my distance from him. So I walk toward home. At a rate of 2 miles per hour. There's that statement about our rate. Finally, the question part, which is, I'm going to start with how many, looking at my y value, how many miles? From home am I after X hours? Simple, very formulaic. Write a sentence that tells you the real world meaning of your starting point or your y-intercept. Write a sentence that tells you a real world reason about your rate, and then ask a question. How many y miles am I away from my house after X hours? Very formulaic. Now, if you want to get more creative, go for it. Add in all the little details that make a story great. These are the things that you have to have, all right?